Okay, so let's look at another one here. We've got number 17, the antiderivative of x squared plus x over x cubed minus x plus x minus 1. So once again, back in chapter 4, we'd say, hey, we can let u equal the denominator, du equals 3x squared minus 2x plus 1. We don't have that in the top, so we can't really get rid of it via substitution. So what we want to really do is we want to try and factor this out. So both the numerator and denominator would factor. In this numerator, we can always look at taking out the greatest common factor, that'd be x, and we can rewrite that as x times the quantity x plus 1. The denominator is a little more challenging. We've actually got 4 terms, so we need to go back and dust the rust off of our algebra skills and say, okay, well, how do we factor when we have 4 terms instead of 3 in descending order? So what we can really do is split that group of 4 into 2 and 2. And so what we could do here is look at these as x cubed minus x squared and as plus x minus 1. So we can kind of group these together. And if I do that, I can pull out a greatest common factor from x cubed minus x squared, and I'll get x squared, and I'm going to be left with times x minus 1. And that's actually what I have here. So I could write this as plus 1 times x minus 1. And if I notice, then I have a common factor of x minus 1 that I can pull out in front here. And I'm going to be left with the x squared plus 1. And the sum of 2 squares does not factor. So basically on the bottom, this is what I'm going to get on the bottom. This is what I'm going to get on the top. So what I could really do is try and figure out now, how could I rewrite x times x plus 1 over x minus 1 times x squared plus 1. And so what I really need to do is I need to split this into 2 parts. The first part is going to be over x minus 1. So I'm going to use my partial fractions here. And so since the degree of this is 1, I just need an a up there. And on the second part, I've got x squared plus 1. And so since the degree of this is 2, I'm going to need a bx plus c. So I'm going to need a first degree equation up on top. So this is what I want to rewrite. So I can rewrite this as a sum of 2 integrals on the right side. So now I just really need to figure out what a, b, and c are. And so to do that, what I can do is I can multiply both sides through by the denominator, or the least common denominator, which is actually x minus 1 times x squared plus 1. And if I multiply that through on both sides, x minus 1 times x squared plus 1, and multiply each part, the distributive law applies on the right. So on the left, I'm left with x times x plus 1, just the numerator, because the denominator would fully cancel out. And on the right side, the x minus 1s would cancel in this term, and I'd be left with a times the quantity x squared plus 1. And then plus, now bx plus c, I'm going to put that in parentheses because the numerator is still there. The x squared plus 1s cancel out, and I'm going to be left with an x minus 1. But it's that whole quantity times x minus 1. So this is really what I need to use to figure out a, b, and c here. So let's go ahead and do that. Let's pick some easy numbers here. Just kind of go through and say, hey, what can I plug in for x to maybe get one of the terms to go away? Well, right away, this x, if I let x equal 0, then what happens? On the left side, I'm going to get 0. On the right side, I'm going to get a times 0 squared plus 1 is 1, so that's 1a. I'll just call it a, plus, and then this term, 0 minus 1 is negative 1, so it's minus 1 times the quantity bx plus c. So I'm just going to rewrite that as minus bx minus c. But then I'm going to rewrite this a little bit too, because what do you know about minus c? Is it an x term or is it a constant? It's just going to be a constant. So I'm going to rewrite this as 0 equals a minus c, that's the constant term, and then minus b times x. So Now we got three unknowns and only one equation. So you might say, well, this is a little bit tough, but if I rewrite the left side 0, how many x's do I have over here? I have 0 x's. So I could rewrite this as 0 plus 0x plus 0. So I have 0 x's plus 0 is the same as 0. So the question is, how many x's do I have? Well, I've got 0 x's, and so minus b times x, the opposite of b is going to be the opposite of 0, which is 0. So I can actually conclude here that b equals 0, which is definitely going to make my life a lot easier. So then the other equation I have here is that a minus c is actually going to be equal to the constant term, which is 0. So I also know that a minus c equals 0. Well, there's a lot of different options for that. I could have 5 minus 5 is 0, or 10 minus 10 is 0. So we need some more information on that. But certainly plugging in x equals 0, if you rewrite the 0 as 0x plus 0, we can see that the b term has to be 0. Now that can also make this easier, so I can just go ahead and get rid of it because I know that b times x is 0 times x. So really, the right side is just a times the quantity x squared plus 1 plus c times the quantity x minus 1. And then we can keep going here. So the next one I could let be 0 is this term, x plus 1 term. That would happen when x equals negative 1. So if we let x equal negative 1, what do we get? We're going to get 0 on the left, and then on the right, negative 1 squared is positive 1 plus 1 is 2. So I get 2a, and then negative 1 minus 1 is minus 2, so minus 2c. So I'm going to get 0 equals 2a minus 2c. If I divide everything by 2, I get 0 equals a minus c. That doesn't give me anything new, so that didn't really help us at all. So let's see if there's one other thing we can find here. I can't plug in anything for x squared plus 1 to be 0 because x squared is greater than or equal to 0, and if I add 1, it's going to be greater than 0. So there's no value I can plug in here to get 0. So what about this one? If I plug in 1, if I let x equal 1, what do we get? If x equals 1, then I'm going to get, on the left side, I'm going to get 1 times 1 plus 1 is 2. So on the left side, I actually get 2 this time. And on the right side, 1 squared plus 1 is 1 plus 1 is 2. So I'm going to get 2a. And then over here would be 0. So c times 0. So anyway, 2 equals 2a. Well, that gives me what a is. A equals 1. And so then plugging that back into either one of the other ones, 1 minus c is 0. So that says that c is going to actually equal 1 as well. So 1 minus 1 is 0. So now I have that a is 1, b is 0, c is 1. And so what I can do is then rewrite this antiderivative up here as the antiderivative of these two parts. So this is going to be equivalent to, once again, a was 1. So this is going to be the antiderivative of 1 over x minus 1 with respect to x. And then plus, once again, b was 0. C was also 1. So this is 1 over x squared plus 1 dx. And so we have this. So basically it becomes a very nice version over here. Now you can use substitution, let u equal x minus 1, du equals dx. So that's kind of like the integral of 1 over u, which is a natural log of the absolute value of u plus c. But I'm just going to go ahead and cut to the chase. It's the natural log of that denominator here, x minus 1. If I take the derivative of this, it's 1 over, and then chain rule times derivative of what's inside, which is 1. And that's what I have here. So this is just natural log of the absolute value of x minus 1. And then plus, this other one is set up to be arctangent. So 1 over a, of course, a is 1. That'd be 1 squared, right? So 1 over 1. Arctangent of x over a, which is just arctangent of x, arctangent, and then plus c. So this ends up being the final answer there. And of course, we could take the derivative of this and make sure we end up with what's in between the antiderivative and the dx here. But I checked in the back of the book, got the answer, and boom, stick a fork in it, we're done.